Hi everyone, welcome on YourPedia Education. And as you know, we are publishing the interaction with professors on the basis of our penetration to first ever research and development fair, which was held in IIT Delhi in October 15, 2022. Many projects from different IITs were presented there. And this video today is related to one such project on electric vehicles. So there was a project, a novel induction motor for EV propulsion applications. And Dr. Ranjan Kumar Behera from IIT Patna is the researcher who has made this particular project, who has got this executed. And I got the opportunity to interact with Professor Behera today. And we had a lot discussion about that. E-vehicle, as you know, is the latest domain and latest technology which we are trying to acquire. Dr. Behera is authority in the field of design and fabrication of power electronic circuit, electric vehicles. He has done marvelous work in electric vehicles. So we will discuss a couple of concepts like green energy, electric vehicle, future of electric vehicle in India, why AC induction motor for electric vehicles, what are the challenges. So those kind of things we will be discussing. And I'm very sure those of you who are related to this field of research, they will get immensely benefited through this interaction. So let's go and interact with Dr. Ranjan Behera. Good morning, Professor Ranjan Kumar Behera, and thanks a lot for your time and welcome on YourPedia Education.
Thank you. Thank you very much.
Professor Behera, you are doing marvelous work in the field of e-vehicles, electric vehicles, and domain of your research areas are electric drives, design and fabrication of power electronic circuits. These are some of the research areas in which you are working. And recently, sir, one of your projects, that is a novel induction motor for EV propulsion applications, was displayed. That was in IIT Delhi, first ever R&D fair, which was conducted on 14th and 15th of October. This is a very novel concept, as the name shows, sir. And this entire interaction will be related to the knowledge we want to get from you related to e-vehicle, जो एक recent India के अंदर we all want that and recent trend है. So many youngsters want to pursue their career in e-vehicles domain. उसके बारे में जानना चाहेंगे sir, and I have made a questionnaire of some interaction points. So I will keep on interacting on those particular points. So if you permit me now, I will start the entire process.
Please go ahead.
Okay.
Thank you.
Professor Behera, first my point is related to the project only itself, जो display हुआ था IIT Delhi में. The name was a novel induction motor for EV propulsion application. Please tell us something about that project.
It is novel because the first thing is whatever induction motor you get from the market, the efficiency is around 63 to 71%.
Okay.
So whereas this induction motor, first we targeted for 90% efficiency.
Okay.
And second one is because the efficiency is very high. And also Indian roads are not like foreign roads. We have humps. The roads are muddy road and village road, so many kind of roads. So you require wide speed range. That is why we have taken the frequency which is higher than our Indian standard frequency of 50 hertz, generally our Indian frequency, grade frequency, whereas we designed this one 80 hertz.
Okay.
Because 80 hertz can have two times the base frequency, you can have flux weakening, so wide speed range, because somewhere you have to, there are humps, some roads are not good, so you require a wide speed range. So that is why this is designed especially for wide speed range and especially for Indian roads.
Okay.
And that is what it is, innovation. And also the size is half of the 5 HP motor you get from the market.
Okay.
Which is very important for electrical vehicle, high torque to weight ratio. That is.
So there are some advantages, as you mentioned, sir. Efficiency की term में advantages हैं, और आपने इसको indigenize करने की try किया है for Indian situations and Indian conditions. Wonderful, sir. Professor Behera, you have done marvelous work in different areas of specialization, and my next questions are related to that only. There is a term called green energy. That term is very catchy, sir. That is very relevant for today. So we want you to explain us what do we mean by that green energy first, and what do you feel the possibilities of green energy in Indian context?
Okay. So generally, the green energy we speak that purely renewable source of energy.
Yes.
And everywhere there are a lot of projects all over the world people are doing, and it is today India's requirement also.
Great.
So green energy, but there is only one limitation is that because it is intermittent in nature,
Right, sir.
so it is not a continuous flow of energy. And that is what the green energy required a lot of research, especially in Indian context. For example, we have planted a few solar plants also different part of Bihar. But sustainability of those plants is very difficult because first thing is proper trained manpower are not available. People, they don't want to live in the villages to run those projects. And those who are staying there, they don't know anything about that except turning on the light and bulb. So green energy for other country, it is very catchy. Actually, they will very nicely utilize, they know the technology. Whereas in India, when you deployment, everything need to be done according to time, situation, and where you are putting. It's not that whatever is suitable for Bombay, it will not work in the Patna villages also. Because there are the surroundings are different, here surroundings are different. And India get 3 top tropicals. So the 3 type of sun rays, 3 type of sun tracking, many things are required. So a lot of research is needed, and especially today, very robust thing is required for India. Because in India, when we put a simple converter, inverter, so sometimes converter is fault, or in the inverter is fault, or sometimes our wires are fault. People, they don't know. That's why more robust technology need in India, and lot of things we designed here at IIT Patna also. Hybrid, wind, solar, many things we designed. Okay. So India required like that technology today.
Yes, sir, and that is the also requirement of sustainable development goals, which we know. So that is required, sir, and that is very relevant domain to work in. Professor Behera, my next interaction point is even more relevant and even more interesting for many students over there, and that is related to electric vehicles. Sir, this is a buzzword nowadays. E-vehicles. Students say, everybody says, and that is a requirement because we want to shift over to renewable sources, and we want to do away with the fossil fuel based technologies. So I want you to tell us, sir, the future of e-vehicles in India.
So in India required different kind of e-vehicle. First thing is India required very robust and very rugged, and it required less maintenance, and also magnet free. In India, requirement is that one, when you have a magnet, when the temperature rises, magnet will demagnetize sometime.
Yes, sir.
If it is not properly designed.
Yes, sir.
And second one, when the temperature rises, you will get demagnetized. So magnet-based motors will not suitable for Indian roads. First thing. Second thing, when you have some kind of low temperature drive, so there will be your inverter problem, or even your battery management problem will come into picture. So you require some kind of robust, like Indian Railway. Indian Railway, we use it to, we have traction motors, and very rugged and robust. Sometimes overhead line 25 kV even breaks. Still, it is so robust that the train stops there, but without damaging the converter, inverter, whatever auxiliary circuit existed. So in India also, we require such type of motor. That is why we choose induction motor, because once you fit it, for 25 years, you need not to touch that one. Like a pop set you put outside the environment, it runs for 25 years. You cannot even understand that there is any fault in induction. That is what India requires induction.
Wonderfully said, sir. And I totally agree. Indigenization is required, or Indian की requirements के हिसाब से जो आपने points बताए हैं, sir, they are required, and that will be wonderful if we come to that particular situation. Next, I want to ask you, sir, about electric vehicles only and the technology part of electric vehicle. Normally, electric vehicles have DC motors, and you have proposed AC induction motor for electric vehicle. So I want you to tell us why that is so.
You see, the DC motor actually requires a lot of maintenance. Maintenance, because the small electric low power EV, you can use a DC motor, there is no problem. But when you come to a little higher power, and where a lot of 4-quadrant operations are required, like forward motoring, reverse motoring, forward braking, reverse braking. So you require a lot of time. You need to reverse the current in both the direction. If a DC motor, if you reverse the voltage and current always, you will see that there will be large number of spark, and your brushes, they will damage very quickly. That is why Indian Railway also, you see that statistic in Indian Rail, when there was a DC traction motor, there are a lot of maintenance. That's why 1998 onwards, India government standardized all traction motors should be long drive trains. They should be AC traction motor. So from there, AC traction motor came into picture because easily available power converters like IGBT is invented, and IGBT became very popular today. And due to the sophisticated control, easy control, the induction motor control exactly like a DC motor, we can control induction motor. There is no problem. Okay. So for high power, DC motor require large maintenance, and everybody cannot do also maintenance. So that is why AC motors are best fitted for India.
So main reason is maintenance.
Yes, maintenance.
Dr. Ranjan, electric vehicles require wide speed range, high efficiency, and large number of batteries. For a wide speed range, more batteries need to be connected in parallel. What all challenges appear when several batteries are to be connected in parallel?
First thing is actually charge-discharge cycle of individual battery are always different.
Okay.
And second thing, there's one battery and there are multiple number of batteries. The thermal management of one battery is different when you pack it in a small container. So when you just pack it, the temperature rises are very exponential. So how to cool and how to design such thing, and especially when we have this kind of a battery structure, when your electric vehicle moves in a torn surface, like you have to go around a road, and it is round shape, you will see that the wheel which is extracted maximum torque, that battery will discharge more. Which is having less torque, that battery will not discharge more. So charge unbalance will come. As soon as charge unbalance will come, your vehicle will start vibration. So as soon as the vehicle mechanical vibration started, and SOC, state of the charge of the both battery will be different, that time you bring to balancing both the charging required fast charger or fast energy transfer circuit, which is the main challenge today. One is thermal management, second one SOC balancing, third one how to control the discharge current when this type of situation arises. So these three are main problem in the battery today, and that we are now studying also.
We're trying to find a solution to that.
Yes.
Okay. Professor Ranjan, these induction motors are normally used with very costly variable frequency drives, which we call VFD, to control the speed. How are you controlling the speed of induction motor that you have proposed?
Okay, this induction motor we designed with a distributed inverter.
Okay.
That means we have three phase we separated three phase, and each phase is controlled by one inverter. So rating of the inverter became very low, and the size will be very compact. And also it is modular. If one inverter is not working, you just change that part of the inverter, which will not affect on other tubes. If integrated three-phase inverter you take, it will become bulky. Also, it will also one module damage, it will affect on other modules. So this is what we have designed, a distributed inverter.
Okay.
Three inverter distributed, and they are very compact. And also battery requirement, you see three inverter and three phase, you required three times the battery current, battery voltage.
Right.
Whereas here only single in phase, you require less number of batteries. That is how we calculated and we designed that one.
Okay, Professor Ranjan, you are presently using a bulky inverter of the size about 5 cube feet to convert DC supply from battery into AC. This inverter is additional entity that will add to the cost. It will result in energy loss also, and also consume much space on the chassis of the vehicle. In view of these factors related to inverter, will market accept your innovation, sir?
So actually, this inverter, what we have shown in the R&D phase,
okay,
that was actually not our inverter.
Okay.
Because our inverter is already connected in the chassis. Within the chassis, it comes very small, thin.
Okay.
But what we have taken, which is built in the laboratory purpose.
Okay.
So that is why it was looking so big. But our inverter is just 1/4 of that one, that size. So where in the R&D phase, because we took, because there may be some vibration will come, some this disconnect will come, there may be some disconnection. That is why that inverter we have not taken, because it is not properly packed.
Okay.
So we took which inverter is packed. That's why our inverter is very small. And also efficiency is more than 96%.
Okay, wonderful.
Our inverter efficiency. And also it is very compact in size. Within the chassis, you can properly you can keep that.
So now we have also experimented with our own inverter also, sir.
Yes, we have experimented, and that is also published in a paper.
Wonderful, wonderful. Professor Ranjan, why do you feel that usage of your motor in a typical electric vehicle will need lesser batteries?
Actually, because I told you, we have divided three phase into single phase.
Okay.
Open and winding. So each phase is feeding from one battery.
Okay.
Like when you have coupled three, you require 3 kilowatt. When you divide that one, you require 1 kilowatt. Now you will, how many batteries will connect in series and parallel? We optimized that one. The optimization technique we did, because this is project was sponsored by NAMPET, National Mission for Power Electronic Research, Ministry of MIT, Ministry of IT. They have sponsored this project, and they required less number of batteries to be connected. So we optimized it. We have shown in that technical phase when you attended, we have shown there that when you have a three phase, you require 24 number of batteries, and also parallelly 24 number of batteries, and they will be also in the parallel and series. Whereas in the single phase, that is 8 number of batteries you required minimum, and also we have shown that there are 2 parallel paths are not required. Only single parallel path can cater that one. So that is why we optimized the requirement of this one according to the track condition. Also, we tested with different the track profile also. Like vehicle moves in urban road, in a rural road, all these things we tested.
Professor Ranjan, you have already answered to my question, which I'm going to ask you again, but still I would like to ask her. You were giving the name of your project novel induction motor. What I understand is that there is some novelty or newness in that. So I want to ask you again, sir, what is new in the induction motor that you have designed?
First thing is I have already told the efficiency.
Yes, sir.
Second one is its frequency. Third one is its size.
Okay.
Fourth one is the operating voltage.
Okay.
Is 110 volt.
Okay.
5 HP. You will find in the market 440 volt,
Okay.
5 HP motor.
Okay.
But this is 110 volt because the battery, you require less number of low voltage batteries are needed for that one.
Okay.
And that is why it is designed. And fourth thing is that this motor, you can operate like a maximum power point tracking.
Okay.
Like your solar ray changes a whole day.
Mm.
So you get maximum power point, whatever the power you extract from there, maximum power.
Okay.
So similarly, in all typical speed conditions, generally if you go from no load to full load,
Right.
you will find that the efficiency reduces when the load is very low.
Right.
And but this motor, you can maintain the efficiency in all load conditions. This is the novelty in this.
This is the novelty. So all load condition may we get. So what is the range of efficiency we get in all load situations, sir?
All load situation with the inverter, we try to control adaptive load performance efficiency, adaptive loss minimization technique, by which we maintain the efficiency from 87% to 89% in that range for all load conditions.
Okay, but that
which
is
till today, which is till today is very difficult for EV manufacturers.
Yes, yes, that is true, sir. That is a really very good efficiency which you are telling, sir, for all load situations. Now, my next question is related to fabrication, Professor Ranjan. So, how did you do fabrication of the motor which you designed, and was that done within IIT Patna campus or it was outsourced?
No, we have designed the motor.
Okay.
Motor we have designed, but after that, because this frame size is not available in India.
Okay.
So you require a different frame because our frames are meant for 50 hertz to 440 volt. And this is 110 volt and 110 volt and 80 hertz machine. So this first thing is the frame size. We cannot get it. So one manufacturer, integrated electric from Bangalore, they agreed to manufacture this one.
Okay.
And then we design this and we give them that motor. And they told us that it is impossible. Again, 2-3 times we have to visit the lab. We have to see that how they are all kind of winding, other structure, everything. So after that, it is after 4-5 iteration, perfectly the motor is designed. It's not that directly we design. Okay. There are 4 sets we destroyed. Actually.
Wonderful. Dr. Ranjan, some electric vehicles, we see that there is a motor, gearbox, propeller shaft, then differential, and finally axle shaft. Whereas in some electric vehicles, we find that motors are directly coupled onto the tires. How do you compare the two designs?
Actually, a hub motor, we also design hub motor. Just a few days back, we have given to one company. It's called Nemo Power System, Bangalore. Okay. We have designed the hub motor, BLDC, brushless DC motor for them. So these are very good for the low power motors. Hub motors for the electric big like a heavy duty drives, heavy duty car, heavy duty vehicles like bus, truck. It is very difficult actually because you have inside the motor, one is thermal management. It is very difficult because it is a hub motor, it is on the wheel. So if there is no proper cooling, and third one, in the wheel there is always vibration. So the mechanical failure are more in case of the hub motor. That's why people prefer mid-drive motors, so that there will be some gear, it is connected. Even though there is a mechanical vibration, it will break the gear. It will not transfer to the motor side. So that is why those motors are good when it is low power and low power motors, and also it is these hub motor are very popular also.
Okay, wonderful. So that means that is more used nowadays.
Yes.
Okay.
So hub motors for low power application, they are good.
Right.
Like one company approached just Pulsar.
Okay.
They approached us to design a small hub motor for drone application.
Okay, drone application.
So these are very, they would require 300 watt. So that is very good for hub motor. But when you go for very high power, the induction motor is the best.
Okay. Dr. Ranjan, my next question is related to very, very important and relevant domain in e-vehicle, that is lithium-ion batteries. Increasingly, lithium-ion batteries are being used instead of lead-acid-based batteries. Unfortunately, our nation has very limited and less lithium resources. Researchers are trying to develop sodium-ion batteries and also trying to develop hydrogen-fired vehicles. What are your thoughts on this, sir?
Actually, in India, the lithium-ion batteries, what we think that it will give good efficiency, very nice, but actually it fails in very less number of cycles.
Okay.
Like nowadays, our lead-acid battery can give 500 cycles per battery. Okay, after 500 cycles, they may. Now they are trying to increase up to 1,000 cycles. Okay. So lithium-ion battery, they say that you can do up to around 1,200, 1,500 cycles per battery. But actually in India, I have also purchased, and one of the three-wheeler we have, we transfer our lithium-ion, lead-acid battery, lithium-ion to lead-acid battery. But completely it devastated in a few days only.
That means the claim that it is 1,000 cycle, it is not.
No, practically it is not, because India, this is our battery system must be robust. And it is not that robust actually, because in that pack, how it is mounted, how it is, you cannot even understand. They pack it and give to us. How that thermal management is taken care of, how the cell level they try to balance. Nothing we know. We only purchase and we just put it.
Okay.
And as far as sodium and hydrogen, these two elements, the hydrogen, it requires a lot of, because the energy density is very low actually. And although the sodium ion battery they are designing, but it is a very small scale. It requires a lot of research on this one actually. When we will go for EV range of application, it requires large research and packing, methodology of that one, so many things.
So that means we should, Professor, go to lead acid batteries only in India? Is that what you are saying?
And that is only the best part, because till now I have 2-3 vehicles I have developed. Okay. And I have studied, but I have not seen other batteries, but at least lead acid battery is this I have.
Okay. Professor, my next question is related to again DC motor and AC motor. So there's a perception, I don't know how true it is, that we want to know from you, that it is much easier to control a DC motor rather than AC motor. So to what extent this perception is true?
Yeah, this is true.
Okay.
Very easy and simple control is a DC motor.
Okay. But then you were mentioning about maintenance part, sir. You said that the maintenance of DC motor is difficult.
Very costly. Okay. And now that is why you see in our electric, all the hot strip mill in steel industries, you will find there were DC motors. But after invention of IGBT, the microcontroller, microprocessor, AC motor control became easier. And nowadays, I can control the AC motor like a DC motor. And that is called the vector control or field-oriented control. I can just treat my AC coupled motor like a DC motor only. And that is called the vector and field-oriented control. That way you will get better efficiency than the DC motor also, because DC motor, we have a commutator, brush, other thing. And they require large amount of voltage drop also there. Whereas AC motor, there is absolutely rugged. That is why we use.
Okay, wonderful. Dr. Ranjan, your motor, when instrumented in a vehicle, would also need a software to control the motor and to control the batteries. Please tell us about the need to have electronic control unit, we call it ECU, and associated software in an electric vehicle. And are you working on this particular aspect?
Yes, actually software we don't design.
Okay.
Mainly we have hardware. Okay. And what especially controller we purchase from some company, for example, Texas Instrument or D-Space.
Right.
So we have a software, we use MATLAB.
Okay.
And we can develop the program, and that program we load on the hardware. Right. And the hardware runs that one. Right. So that is why software part we don't, because we have already MATLAB IIT purchased. And nowadays all processors run by using MATLAB. So you load the code and just dump it in your hardware processor. That runs the motor. That's why it becomes nowadays very easy, plug and play kind of thing. That's why the electronic controlling is not at all very difficult today. And I have seen during my MTech, we need to write 400 lines of code to fetch one data. Whereas now, just a student, nothing, just build it, it will be done. This is very simple.
Okay. Dr. Ranjan, my last question on the script today is related to the future of control theory. How do you see the future of control theory with emergence of new concepts, new technologies like artificial intelligence, machine learning, data science, and deep learning, these kind of new technologies? And do you feel boundary between engineering streams is vaporizing now?
Yes, nowadays actually there is no boundary. Okay. Like we were studying a battery cycle prediction. So battery cycle prediction for lithium ion battery and for lead acid battery, we did. So we used machine learning, data analytics, all those things for the drive control, for drive maintenance, for reliability issue. So we required a lot of data and analysis. After analyzing the data, you can give a prediction. So all these things became concomitant for everyone. Whether I'm a hardware engineer, whether a software engineer, this part becomes very easier for everyone.
Yes.
And everyone, they will learn this thing. Nowadays, because everything comes with a processor, so processor required generate the data and you analyze, give the reference comment that you have to do like this. So for example, I remember when we were using big induction motor in Abu Dhabi, when I was working, you will go to inside desert and there is a lot of digging. So you dig that one, whenever you will find there is a liquid source, you stop digging there. So like that you run the motor whole night and put just a simple throttle controller, so that the time they will touch it, they will open the circuit, so motor will stop. So you will understand that, okay, at this point there is some liquid source. So like that, simple control we use, and this same control you can use your prediction layer by using artificial intelligence, and you collect from data lot of years, and that data, based on that data, you predict that after this many kilometer, you will get a water source. Like that, we can predict.
That's wonderful, Dr. Ranjan. So that brings us to an end of this wonderful session. Lot of information, but I will ask you two more questions, sir, which I normally ask the people and the experts like you. Sir, I will ask you, like the domain in which you are working, electric vehicle, ये बहुत ही ज़्यादा demanded एक domain है, sir. Students want to pursue their careers in this. Maybe those students who do not have knowledge also, they keep on saying e-vehicle and all. And also they keep on using the terms data science, machine learning. These are new things actually. they may be looking for their jobs and opportunities, further opportunities and all, and different domain of knowledge, student from mechanical engineering, electrical engineering, electronic engineering, computer science. So I want to ask from you, sir, what are the latest areas for doing small projects in graduation? If some student is in graduation, how can he groom himself for career in these kind of areas? How he should proceed, and कौन सा research areas बहुत ही ज्यादा important है जिसमें वो अभी अपने graduation में he should focus? Maybe he goes for internship there, maybe he does his project related to that. तो ऐसे कौन से areas हैं which you can suggest them, sir?
You see, we work in many areas and easy. First thing is when our summer interns also come to me.
Okay.
So one BIT Patna student, 3 students they came.
Okay.
So I told them, you design an electric vehicle.
Okay.
And with 20,000 rupees only.
Okay.
And I gave that task.
Okay.
And they could able to design from somewhere they collected and 1 kilowatt motor they purchased and they have designed a very low cost system they have designed. And it is a very small thing. So in electric vehicle, first thing is the charging infrastructure. Different kind of charging, wireless and wired charging. So kind they can work very low cost, starting from 1 kilowatt charger, 300 watt charger, up to 250 kilowatt charger.
Okay.
And in the electric vehicle part, motor design, motor modeling, and motor control, and also motor deployment to the vehicle. Then studying the mechanical dynamic, vehicular dynamic, also another part of that research, where you will predict what kind of road structure you have, and what kind of torque you need to generate from the motor. And third part is the completely controller of the battery management system, controller, and complete the drive control system with battery management. That is also another part. Fourth one is that different road profile study and battery life cycle prediction and balancing problem. There are also a lot of study we are doing. So also from solar, how to charge. Solar chargers are nowadays very attractive nowadays. So that also we need to look into.
Okay, wonderful. My last question of this entire interaction, Dr. Ranjan, is when students listen to people like you and when they see your profile on the website, they have this kind of dream to work under the guidance of people like you, maybe in the master's or doctorate or something. So what do you see in your prospective students, Dr. Ranjan, when you hire them or when you select them for their specialization under your guidance for master's programs or PhD programs? What do you see in them? So what ingredients they should have?
First thing I see that they have a little fundamental clear where they want to work. Second one, their interest.
Okay.
And third one, their humbleness to grasp the knowledge.
Okay.
These 3 things are main important thing for a Vidya. That's why in Bhagavad Gita it says, Vidya Vinaya Sampanna Brahmana Gavihastini Sunichena Sapakecha Pandita Samadarsina. A Vidyarthi must have this character. If he is no character like this, even though he is very knowledgeable, he only will devastate in his future. That's why Vidya means they must be humble. And when they are humble, they will learn the thing. If they are not humble, they will not do. That is what in Bhagavad Gita, very nice.
Truly. So what a wonderful end of our entire discussion with the couple of lines from Bhagavad Gita, sir. It's wonderful this morning. So let me again thank you, Dr. Ranjan, for sparing your time this morning. And I collected almost 20 interaction points, and you provided a very beautiful explanation to each one of that, sir. But simply way में आपने बताया. एंड आई एम वेरी श्योर जो स्टूडेंट इसको सुनेगा, जो रिसर्चर, जो एंटरप्रेन्योर सुनेगा, इंडस्ट्री के लोग सुनेंगे, उनको बहुत बेनिफिट होगा, बिकॉज देयर इज अ गैप एक्चुअली. पीपल लाइक यू हु आर फुल ऑफ रिपोजिटरी ऑफ नॉलेज, उनके व्यूज आगे अगर जाएंगे तो उनसे बेनिफिट होगा सर. एंड आई एम वेरी श्योर यू हैव डन मार्वलस जॉब इन दैट डायरेक्शन. थैंक्स अ लॉट सर, एंड नमस्कार.
Thank you very much. Namaskar.